Okay, so here we are doing the Tech Math 1 packet. So here we go. Simplify the following. First thing I'm going to do is I'm just going to distribute the exponents to everything. So 2 to the minus 2, m to the minus 12, p to the minus 10, 4 to the minus 8, over m to the positive 4, r to the minus 18, and that's all times m to the minus 21, p to the 24, r to the third, all over 2 to the third. Okay. So what have we got? We've got 2 to the minus 2. Well, here, let's do it this way. I'm going to draw a fraction bar. 2 to the minus 2 is going to drop down here and become 2 to the 2. M to the minus 12 divided by m to the 4 is going to be m to the minus 16. So m is going to come down and be m to the 16th. P to the minus 10 is going to drop down here and become p to the 10. R to the 18 is going to go up here and become r to the positive 18. And then 4 to the 8th is going to come down here. Sorry, 4 to the minus 8 is going to come down here and become 4 to the 8th. Okay. And then another fraction bar, p to the 24th stays up here, r to the third stays up here, 2 to the third stays down here, and m is going to move down, m to the 21 is there. Okay, so now what have we got? We've got r to the 18 and r to the 3, so that's going to be r to the 21. We've got p to the 24 over p to the 10, so we subtract, that's going to be p to the 14. We've got m to the 16 down here and m to the 21 here, so that's going to be m to the 37 total. And then we've got this really, really big number here, 4 to the 8th times 2 to the 3rd times 2 squared, which I didn't intend to be so large, but it is, so let's just multiply that out and see what it is. So 2 squared, or let's start with 4 to the 8th. So 4 to the 8th times 4 times 8 is 2,097,152. So yes, sorry about that number. I think I intended it to be something else and it was a typo, but we went with it. So that's our final answer. Okay, next. This is a nice and easy one. 12 over 3 is 4. M to the 19th divided by m to the 5th is m to the 14th. N to the 9th divided by n to the 6th is n to the 3rd. Okay, next. Let's see what we can do here. So 108 I know is 9 times 12, and 12 is 4 times 3, so that's a pair of 3's there, and that's a pair of 2's there. 75 is 3 times 25, and that's a pair of 5's there, so we can rewrite this as, what have we got? 3 times 2 is 6, root 3 minus 5 root 3, and so that'll just give us root 3. Number 4, we've got to multiply by the conjugate, so it's 3 minus root 7, top and bottom. So what have we got here? Foiling on the top is going to give us 12 minus 4 root 7 minus 3 root 2 plus root 14. And on the bottom we get 3 squared minus root 7 squared. So we've got 12 minus 4 root 7 minus 3 root 2 plus root 14. None of those terms can be combined, and this is going to give us 9 minus 7, so that's all over 2. Okay, next. Hooke's law states that the force needed to stretch a spring is directly proportional. So let's just talk quickly about direct and indirect variation. So directly proportional is y equals k times x. So k is called the proportionality constant. As x increases, y increases. Inversely proportional is y is equal to k over x. So as x gets bigger, as the denominator gets bigger, the whole fraction gets smaller. So here, if x increases, y increases. Here, if x increases, y decreases. So here we've got directly proportional. So we're using y equals k times x. So the force needed to stretch a spring, I'm going to call it F, is directly proportional, so there's a proportionality constant k, to the amount the spring is to be stretched. So I'm going to call this variable S for stretched. If 12 pounds, so that's the force, so 12 pounds stretches a certain spring 2 inches, so that's k times 2. How much will the spring be stretched by a force of 19 pounds? So first we need to solve for our proportionality constant. So divide by 2, and we get k is equal to 6. Okay, so now if we know that the force is 19 pounds and k is 6, we want to figure out how much will the spring be stretched. Divide by 6, and that's going to be 3 1/6 inches is the amount that our spring is stretched. Okay. Number 6. A varies jointly as B and the square of C. So first thing, write the above statement as an equation. So A is some proportionality constant because it varies. And there's B in there, and there's a C squared. So that's it. A equals some K times B times C squared. So if A equals 9, when B equals 2, and C equals 3, find the constant of variation K. So 9 is equal to 6K, so K is equal to 1.5. And what is A when B is 8 and C is 4? So A is equal to 1.5 times 8 times 4. So that's going to be 48. Okay, let's talk about significant digits for a second. So things that are not significant, zeros at the end of big numbers, and zeros at the beginning of decimal numbers, so not significant. Zeros at the end of big numbers or the beginning of decimal numbers. So not significant, not significant, not significant. Things that are significant, any non-zero number, zeros in the middle of numbers, and zeros specifically written after a decimal point. Okay, so I'm going to put a box around the ones that are significant. Sorry. So this whole thing, 601. So those are all significant. The 2, 2, 3 are all significant. This 0 is specifically after a decimal point. It was written there on purpose because somebody measured it to that degree of precision. So they wanted you to know that I measured it with a precision of 1/10 of a unit. So that is significant. So if we look, this has 3 significant digits, this has 3 significant digits, this has 3 significant digits, and this one has 1. Okay, convert to scientific notation. Remember how this works. So we're saying we have to move 1, 2, 3, 4, 5 places. So this is going to be 4.1 times, and since it's a small number, it's going to be 10 to the minus 5. Here, we move 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we've got 7.42 times 10 to the 10. Remember that you always want just one digit to the left of the decimal point, and it can't be a 0. It has to be a digit 1 through 9. Okay. Next, going back the other way, convert to standard form. So 2.22. We're moving it to the left 5 places. 1, 2, 3, 4, 5. So it's going to be 0.40222. In the next one, we're moving the decimal point to the right 6 places. 1, 2, 3, 4, 5, 6. So that's going to give us 6,173,000. All right, hooray for scientific notation. Next, multiply and give your answer in scientific notation. So if we do 4.19 times 3.334, we are going to get 13.96946 times. Now, 10 to the 5th times 10 to the 18th is going to be 10 to the 23. We only want one digit to the left of the decimal point. So if we have to move this decimal 23 places to the right, if we back it up one more space, we're going to actually have to move it 24 places to the right to get the same number. So this is going to be 1.396946 times 10 to the 24. And if we're using the correct number of significant digits, we would write approximately. This is accurate to 3 significant digits. This one is 4, so we always go by the least precise measurement, and so we're going to use 3 significant digits. This 6 is going to round that 9 up, so we've actually got 1.40 times 10 to the 24. Okay, if we look at the next one, let's divide the numbers. So 7.012 divided by 4.087 is going to give us 1.715683875. That's a lot of digits. You don't have to write them all because we're going to be rounding anyway, but I wrote them all. Okay, 10 to the minus 35 divided by 10 to the 9. So we're going to subtract. Negative 35 minus 9 is going to give us negative, oh, you got to write the 10 first. 10 to the minus 44. Okay, and because this is, there's only one digit to the left of the decimal point, we don't have any extra work to do. We have 4 significant digits here, 4 significant digits here, so our answer will contain 4 significant digits. 1.716, again, we're going to round that up, times 10 to the minus 44. Okay, solve the following equations for the indicated variable. So first things first, subtract 2 from both sides. What have we got? The fourth root of a is equal to 4. Then we raise both sides to the fourth power. We've got a is equal to 4 to the fourth, which is 256, I think, but I'm going to double check. Yes, it is. 256. All right, great. Number 18 is just a bunch of distributing and solving. So I'll just do it really fast. 2x squared minus 10x minus 3x squared minus x equals minus 2x squared plus 5x plus 6x minus 96. Okay, so let's combine like terms on both sides first. So negative x squared minus 11x equals, let me just make sure I did all of this correctly. Okay, good. And over here, negative 2x squared plus 11x minus 96. Bring this stuff over to the other side. Actually, why don't we bring these guys over this way? So this is going to come over here. So we've got x squared minus 22x minus 96 equals 0. Okay, what are the factors of 96? Well, 12 and 8, that's not going to help much. 24 and 4, no. 6 and 16, that looks like some combination of that will add to negative 22, or will it? No, doesn't look like it. Oh no, this is a plus 96. Hey, there we go. I knew I constructed this to work out nicely. All right, so it's going to be negative 16 and negative 6. X minus 6, x minus 16. So 6 and 16 are zeros. Okay, next. In this one, we want to solve for a. So first things first, we're going to multiply both sides by 4y squared and get it out of this denominator. So we've got 4y squared q equals a to the 8th, b to the 6th, c to the 5th. All right, we're still trying to isolate a, so we're going to get rid of b to the 6th and c to the 5th, and divide the other side by the same as well. Gone, gone. Okay, so we've got 4y squared q all over b to the 6th, c to the 5th, and that's equal to a to the 8th. So what we want to do is take the 8th root of both sides. So finally, a is equal to the 8th root of 4y squared q all over b to the 6th, c to the 5th. So it's just about slowly and carefully isolating your variable. All right. So remember, when we solve absolute value equations, we're going to get two answers. We've got 2x minus 3 equals 5. 2x minus 3 equals negative 5. So 2x equals 8 and x equals 4. Or 2x equals negative 2 and x equals negative 1. Okay, so when we talk about accuracy, we mean the number of significant digits. And when we talk about precision, we mean the number of decimal places. So they go hand in hand. generally a imprecise measurement is also not going to be accurate, and a precise measurement is going to be accurate. So a more precise measurement will have more significant digits, and a less precise measurement is going to have less significant digits. But specifically, we mean, when we talk about precision, we mean the number of decimal places. So this is precise to the 100th of an inch or something like that. When we talk about accuracy, we mean the number of significant digits. Okay, so when we want to express the result with the proper precision, that means you just add and subtract, and when it comes to rounding, you always go by the fewest number of decimal places. So our final answer is going to be rounded to 2 decimal places in this one. In this one, since 3 is our fewest number of decimal places, it'll be rounded to 3. In these, when we talk about accuracy, we always go by significant digits. So we always go by the least number of significant digits. In this case, this one's got 4, this one's got 3, so our answer would have 3 significant digits. These both have 3. This one has 3, this one has 3, this one has 5, so our answer would have 3 significant digits. And then here, you do everything out, and whether you go by decimal places or significant digits depends on the last step that you do. So in this case, we're going to add and subtract first and then divide. And so you go by accuracy if you multiply or divide, and you go by precision if you add or subtract. So it depends on, I'll write this down, depends on the last operation. Whatever arithmetic operation you do last is what you go by for rounding. Okay, good. Next. How much water must be added to 2 liters of an 80% aspirin solution to dilute it to one that is 30% aspirin? So what we're going to do is we're going to make ourselves a little chart. So we've got aspirin, we've got water, we've got total. And we've got 2 rows in our chart. We have before, we have, oh no, we'll make 3 rows in our chart. So we've got a before in the first row, we've got an after in the third row, and then we've got how it changes in the middle. So at first, we start with 2 liters of an 80% aspirin solution. So we're going to assume in these dilution problems or concentration problems, maybe like let's say you added more aspirin, you'd end up with a more concentrated solution. But in these problems, we're always going to assume we have something diluted in water. So whatever the problem gives you, just assume the other thing is going to be water. So it's 80% aspirin. So if there's 2 liters total, 80% of 2 liters is 1.6 liters. So if it's 1.6 liters of aspirin, it's 0.4 liters of water. That gives us 2 liters total. Okay, so how much water must be added? So it tells us we're adding water, but we don't know how much, so we're going to call it X. Okay, we're not adding any aspirin to this solution. The amount of aspirin is staying the same. We're just increasing the amount of water. That's what's diluting it. So the change in aspirin is going to be 0. So if we add these together, 0 plus X is X. So the total change is X liters, which is just the water that we're adding in. So afterward, the amount of aspirin still stays 1.6 liters. The amount of water is now 0.4 plus X, however much we're adding, and then the new total is going to be 2 plus X. Okay, so we want our new solution to be 30% aspirin. So the amount of aspirin, 1.6, over the total, 2 plus x, is 30%. So that's 30 over 100. And what we can do here is we can cross multiply and solve. So 1.6 times 100 is going to be 160. And this is going to be 60 plus 30x. Subtract 60 from both sides. We've got 100 equals 30x. And so divide by 30, we get x is equal to 10/3 or 3.3 liters if we're rounding to the nearest tenth. So that's how to do these dilution problems every single time. It's whatever your solution is made up of, and water, and total as your columns, before change, after as your rows. Okay, next. A theater group sold 250 tickets to a play. Some of those were discount tickets and the rest were full price. Discount tickets were $6 and full price tickets were $10. If they made $23.40, how many tickets of each type were sold? This is an example of a word problem that wants us to solve a system of equations. So let's look at what we've got. We've got discount tickets and full price tickets, and together they add up to 250. So discount plus full price equals 250. And discount tickets were $6. So $6 per discount ticket, and then $10 for full price tickets. If we add all that up, we should get $23.40. So now we've got a system of equations, and you can solve it however you want. I'm going to solve it by multiplying that top equation by -6 and using elimination. So we've got 60 plus 10f equals 23.40, and then underneath it minus 60 minus 6f equals that doesn't seem right. What's 250 times 6? 1,500. I was multiplying it by too much. Okay, so 1,500. So what have we got? 4f equals 840, divide by 4, f is equal to 210. So 210 full price. That means that for discount, they have to add up to 250, so there must have been 40 discount tickets sold. All right. Number 31, a natural gas pipeline feeds into 3 smaller pipelines. So we've got one pipeline, and then it branches off into 3, each of which is 1.07 kilometers. Oh, no, I'm sorry. I read that wrong. Each of which is 1.07 kilometers longer than the main pipeline. So our main pipeline is actually really teeny tiny. So it's x, and these are all 1.07 plus x. The length of the 4 pipelines is 65.85 kilometers. So we just add up everything. So add all 3 of these up. That's going to be 3.21 plus we've got 4 x's is equal to 65.85. Subtract 3.21 from both sides. We've got 4x is equal to 62.64. Divide by 4. X is gonna be I think 15.46. I tried to do that in my head, but that's not always the best thing to do. So I recommend using a calculator just so that you don't get things wrong, because you just were too lazy to do that. Yeah, see? Shouldn't have done it in my head. 15.66. There we go. So how long is each section? 15.66 is the small bit, and then if we add another 1.07 to it, that's 16.73 is the longer bit. Okay, and next, m is inversely proportional. So remember, that's y equals k over x. So m is inversely proportional, so k over something, to the square root of x. So m is equal to k over the square root of x. And m equals 2 when x equals 9. So 2 is equal to k over the square root of 9. So that tells us that 2 is equal to k over 3, so that k is equal to 6. So what is m when x is equal to 64? So m is equal to 6 over the square root of 64. So that's going to tell us that m is equal to 6 over 8, which reduces down to 3/4. And finally, find the following product. So again, with your exponent rules, so we've got -6, x to the 7th, y to the 5th, z, plus 2, x to the 6th, y to the 4th, z to the 3rd, minus 10, x to the 3rd, y to the 7th, z to the 4th. Okay, and that's the first test done.